When we're calculating areas, we want to be able to calculate how many squares fill up a space. We need to know how many squares are being made here. So to do that, we want to find a length and a width, and a length and a width at 90 degrees. Okay, so that angle has to be 90 degrees to make squares. Now, when we talk about most shapes can be rearranged into rectangles, which allow us to find the square areas much easier. So when we're doing a problem like this, when we take a look at this parallelogram, we can take this section of the parallelogram here and we can cut it off and move it into this space here to give us a rectangle, and that gives us our length times width. So essentially, the base length here of 9 times the vertical height here, okay, again it's got to be at 90 degrees, that will give us the area of this parallelogram. So to find the shaded area then, we want to take away this white space here. So what we can do is either find the whole parallelogram and take away the white space, or we can find the area of the triangle here and then work out the area of the triangle here and then add them together. So it looks like the areas of triangles are going to be a little bit easier. So I'm going to say area of triangle 1 is going to be base times height divided by 2, and so we get 22.5 centimeters squared. Okay, so that would represent this triangle here, and then we have to figure out the area of the smaller triangle. Okay, so we'll call this one triangle 2. So area of triangle 2 is going to be the base times the height divided by 2. Well, we know the base is going to be half of 9, so 4.5. But what is the vertical height? So this is where we have to use some similarity. This triangle, red triangle, is half of the length this way in the same shape, so it should be half the length along the diagonal and also half the length along the vertical. So it's going to be half of that length. So this will be 4.5 here. This length here is going to work out to be 2.5 centimeters. That gives us our base times height, and then we can divide that by 2. Since it's a decimal value, I'm going to use my calculator here. So 2.5 times 4.5, okay, and then divide that by 2. I'm going to get 50, oops, sorry, that's wrong. 2.5 times 4.5 divided by 2 gives me 5.625 centimeters squared. So the total shaded areas, when I add that together, is going to be 22.5 plus 5.625, and that's going to give us an area of 28.125 centimeters squared. Okay, so that's one way to do it. An alternative way we could have done this is actually we could have taken this area here, and since the length and width are half of the original area, this area, the red area, is going to be 1/4 the area of the green. So if I kind of split this in half here and split this in half, okay, going in this direction, like that, we can see that there's 4 of those red triangles in that diagram. So the area of this, if we actually divided 22.5 by 4, we're going to end up with 5.625. Okay, so that would be another way to find the area of the smaller triangle. Here, the diameter of the small circle is 4 centimeters. That makes the radius of the big circle 4 centimeters. So I'm going to find the area of the big circle. So it's going to be pi times r squared. So I'm going to square the radius first and times it by pi. I get 16 pi centimeters squared. Okay, and as a decimal value, okay, that's going to be 16 times pi. And that's going to be approximately 50.27. I got a 265, so I'm going to round that to 27. And that's going to be centimeters squared. Okay, so we want to then take away the area of the small circle. So the area of the small circle is going to be pi times the radius. In this case, is going to be 2. Okay, so we end up with 4 pi centimeters squared, and that's approximately 12.56. So we're going to round that to 57 centimeters squared. Okay, so then the shaded area, okay, or I'll do this in green. Okay, so the area of the shaded is equal to 16 pi minus 4 pi, which is 12 pi centimeters squared, which, if I work out the decimal, is going to be 12 pi. And that's about 37.699. So I'm going to round that to 70 centimeters squared. So that will give us the area of the shaded. Now, one way we can think of this as well is that because this is exactly half the diameter, okay, so this is the diameter, this small circle is going to be exactly half the radius, or half the diameter. It should be a quarter of the whole circle. So if I were to take 3/4 of the big circle, okay, the original circle, that would also give us the same answer. So 3/4 of 16 pi is 12 pi, and that would give us the shaded area. So that's another way we can do it if we understand this relationship between length and area. Okay, so this one here, we're being asked to make 3 views. So we want to make a top view, a front view, and a side view. So I'm just going to start with a front view. Okay, so there's my front view. There's going to be one surface visible. When I make my top view, I want to try to line up the edges. And we're going to see 3 surfaces. So I've got 1, 2, 3 surfaces, and I need to show these in my top view. When I look at it from the side, okay, so I'm going to do a side view from here, I'm going to end up seeing 2 surfaces. I'm just going to give myself a little bit of space here. Okay, again, we want to make the heights match, and we're going to see the bottom, the front here, and then that surface there is going to be this one in here. Okay, so there's our 3 views, and we're going to, what we're going to distinguish is the different surfaces that are going to be visible when we look at the 3 different views.